Hey Gipsters, today we are going to be taking a look at the plate motion simulation that we learned about last week. Today we're going to take a closer look at the mantle. Recall that the mantle lies below the Earth's crust and in some places between 65 to 100 kilometers. Now, because it's so deep, scientists don't know a lot about the mantle. They can make guesses or they can make observations or they can make predictions based on the core samples that they're able to collect during scientific drilling. But it's through plate motion that we really begin to understand the mantle. Let's take a closer look. I'm going to select region 1. And recall that when we looked at our plate motion simulation the first time, this area down here, this cross-section view, gives me an idea of both the Earth's outer layer and then the layers below that. Notice that right now I have a convergent boundary. Recall that a convergent boundary is when two plates come together. They come closer, convergent. Now, if I look a little bit lower, I see that my mantle right now is set to soft solid. Now, recall that fossils in Earth's outer layer are made of hard solid rock. Scientists know that. But this mantle, we're going to make some predictions about it. Let's leave it at soft solid first. I'm going to run my plate motion simulation, and we're going to see what these plates do when they converge on soft, solid mantle. I see as they converge, one is moving closer. They are coming closer because they are convergent plates. I notice that my plate on the left is beginning to overtake my plate on the right as they converge or come closer. I'm at almost 150 million years. And again, this cross-section view, my mantle is on a soft solid. I've reached the end of my model at 200 million years. Examine what these plates did on soft solid mantle. Let's reset time and change the type of mantle that we have. Let's move towards the middle. So a mixture of soft and hard mantle. This is soft solid and hard solid. Let's take and run the model again. Observe what's happening. When I take a look at this as the plates converge, I notice a difference in my top plate this time and how it moved that first time. What is that difference and why is that happening? Here I am, I'm closing in on 200 million years. What's different about where these plates converged this time when they came closer, when they converged, and where they stopped? Let's reset time one more time, and let's go back and make our mantle hard solid. Now recall, if something is hard solid, that's similar to the rock that we find in fossils and that make up Earth's outer layer. Let's run the model again. What do you notice is happening or is not happening? This is technically a convergent plate boundary. I see over here that my time is going, I'm at almost 100 million years. Do you see any shifts here? Why do you think that is? What observations do you see? What can you hypothesize or predict is the reason behind that?